Here's how we use the Ti-84 calculator to find a t-interval and then a t-test for differences of population means, but really the data is paired. So the population is the same people at different times. Let's go into stat and then go into tests, and then we'll go down to t-interval. And what we'll do is we'll put in statistics for now. Let's say we had something where we measured the systolic blood pressures of 7 adults before and after a new diet. And so then we found out that X bar, the difference, we'll now put D bar where we would put X bar. Let's say we found a difference of 5 in that sample. And then we found a sample standard deviation of 10.786. And then we had 7 adults in this, so let's put 7. And let's say we wanted a 95% confidence level, so that will be 0.95. What we do is we go down and press calculate, and the calculator is so wonderful. It gives us our two-sided test connection, because we'll see in the next example, this interval we get the possible realistic means at 95% confidence for the difference in systolic blood pressures before and after includes 0. So it also gives us the data we put in, but it gives us the confidence interval, which is most important. Now let's do the test to see if the mean systolic blood pressure difference is 0 or not 0. So let's go into stat. We'll go over to the test tab and we'll go right down to t-test like before. So then we'll put our statistics in. Let's say we would like to know if it's different than 0 or not, so we'll just put mu0 is 0. And then we'll put X bar, the mean difference is still 5. That's great that it's already in. The same standard deviation and sample size. And we'd like to see if the difference, now we're thinking about the D bar here where X bar is, if we want to see if this difference for the whole population, mu1 minus mu2, the before systolic blood pressure minus the after systolic blood pressure, is equal to 0 or not. So the alternative hypothesis will be that the mean is not equal to 0. And then we'll go and calculate to get the p-value. And so we get our t-test statistic, 1.22. That's not very extreme. We get a p-value, a two-sided p-value of 0.2659. So that is larger than 0.05. So we would not reject the null hypothesis. We'll say with 95% confidence, there's not enough evidence to conclude that the new diet has a significant effect on the systolic blood pressure. And that's consistent with that confidence interval we just got, because the confidence interval included 0. So it said the true mean difference of 0 is reasonable with 95% confidence. Now, what if we had data points rather than the actual difference statistics? That's perfectly fine too. We can go into stat and then edit. We'll press enter. And so I put, for example, I'm wondering if students do better on the final exam than the midterm exam. So I put the same 4 students. This is paired data, their midterm score and their final score. So these are just made up students, but useful for example. We have 4 students, so a sample size of 4. What we do now to get the differences is we go up and make a formula for L3. So we'll do second stat into list. That will give us L1. We'll hit enter, and we'd like to do L1 minus L2. So we'll do L1 minus, and then we'll get the names again, second list L2. We'll go down and hit enter. And then we hit enter because this formula looks right for L3. So here we go. And as you see, it auto-populates the differences in L1 minus L2. So now we have just one list of the differences. And then what we can do is we can go into stat, we can go over to tests and do another t-test. And let's say we'd really like to know using our data rather than statistics. So now we don't even have to calculate D bar or the standard deviation for the difference data. We can just put the data right in. We're still testing against mu0 equals 0. That's our null hypothesis for this situation. We'll put in our list. It's already L3 because I had that before, but if you wanted, you could go second stat into list and just do L3 and enter there. I didn't do a frequency list, so that's just 1. Now let's say we really think the students are going to do better on the final exam than the midterm. In that case, we're trying to see if the difference, since we had difference mu1 minus mu2, that should be negative, because if mu2 is bigger, the final is better. When we subtract mu1 minus mu2, we take a smaller number minus a bigger number. It should be negative. So less than 0, that's a left tail test. Now we can go over and calculate the p-value. And so the p-value is 0.057. So at the 90% confidence level, we would reject the null hypothesis, but we wouldn't at the 99 or 95% confidence level even, because this is larger than 0.050. If you wanted to draw the same test, because it's quite beautiful, you could do that too. We could go to Stat, then over to Tests. It's a t-test still, so we'll go that. Keep everything else the same. And now let's just draw it. You could pick any color you like. Oh, I like this brown. Let's put that. And then we'll go over and draw it with the enter button. And so it'll draw this t-distribution. We have 3 degrees of freedom because we have 4 paired data points. So n minus 1 degrees of freedom. And so here is the region of interest. And as you can see, the p-value, it'll tell us in a moment, is 0.0573. And the test statistic is minus 2.2047. So that's here a little more extreme than -2. Great job.